Hello everyone. Now unit 2. The title is Matrix Eigenvalue Problem and Quadratic Forms. Let's see the contents. So first topic is eigenvalues and eigenvectors determination. Second topic is problems on eigenvalues and eigenvectors. Third topic is properties of eigenvalues and eigenvectors. Fourth topic is similarity and diagonalization. Fifth topic is orthogonalization of symmetric matrices. Sixth topic is quadratic forms. Seventh topic is nature of quadratic forms. And the last topic is reduction of quadratic forms to canonical forms by orthogonal transforms. Now we see the definitions of eigenvalues and eigenvectors. So let A be an n by n matrix. A scalar lambda is said to be an eigenvalue or a characteristic value of A if there exists a non-zero vector x such that Ax equals to lambda x. Here the vector x is said to be an eigenvector of A corresponding to the eigenvalue lambda. I am repeating the definition. Let A be an n by n matrix. Scalar lambda is said to be an eigenvalue or a characteristic value of A if there exists a non-zero vector x such that Ax equals to lambda x. The vector x is said to be an eigenvector or a characteristic vector belonging to lambda. So here the geometry of eigenvector is the direction of the vector x is not changed when we multiply with square matrix A. I am repeating, the direction of the vector x is not changed when we multiply with square matrix A. So suppose this is our vector x multiplying with Ax equals to direction of the vector x is not changed, so that is stretched in the direction of x only. So Ax equals to lambda x. So here x is called eigenvector corresponding to the eigenvalue lambda. Now you can understand this definition in the next example. So example. So vector I am taking. The vector x equals to 2, 1 is an eigenvector of A equal to 4 minus 2, 1, 1. So first I am computing Ax. Ax equals to 4 minus 2, 1, 1 and x is 2, 1. So by matrix multiplication, this equals to 6, 2. This we can write as 3 times of 2, 1. So this is equals to 3x. Now what is this? Ax equals to 3x. So what is the eigenvalue? Eigenvalue is lambda equals to 3 and this x is eigenvector. The form should be Ax equals to lambda x. So geometrically, multiplication by matrix A has stretched the vector x by a factor of 3. So the meaning is, what is our vector? X equals to 2, 1. This is our vector. So So multiplying with A, then Ax becomes, what is our vector? 6, 2. So this is 3 times of x. So it has stretched by a factor of, and you can observe the direction of the x and the direction of the ax both are same, or the direction of x is not changing. Such vectors we are calling eigenvectors. Now, computation of eigenvalues and eigenvectors. So, eigenvector definition: Ax equals to lambda x. The equation Ax equals to lambda x can be written in the form A minus lambda A of x equals to this null matrix. Right? What about x? X is non-zero vector. Right? And moreover, it is solution of this homogeneous system. So, when the homogeneous system possesses non-trivial solution, the matrix, coefficient matrix must be singular. Then only it has non-trivial solution. So equation 1 will have a non-trivial solution depend only if A minus lambda is singular, or determinant of A minus lambda equals to 0. This condition based on the eigenvector must be a non-zero vector. This x must be non-zero vector. So in this case, x is solution of homogeneous system. So when the homogeneous system possesses non-trivial solution, this A minus lambda must be singular. Right? Determinant of A minus lambda equals to 0. So if we expand this, we will get one equation. That equation is nothing but characteristic equation. And the roots of the characteristic equation are called eigenvalues. Eigenvalues or characteristic roots. If the determinant into is expanded, we obtain 10th degree polynomial in the variable lambda. Right? That is P of lambda is equal to determinant of A minus lambda. This polynomial is called the characteristic polynomial, and equation 2 is called the characteristic equation for the matrix. Now we see one problem. Find the eigenvalues and eigenvectors of the matrix A equal to -4, -6, 3, 5. So this is our matrix. So first write A minus lambda A. So A minus lambda equals to A is -4, -6, 3, 5 minus lambda into, take identity matrix of order 2, 1, 0, 0, 1, that equal to -4 minus lambda, -6, 3 minus 0, 3, 5 minus lambda. Right? So write characteristic equation. Determinant of A minus lambda equals to 0. So calculate determinant. That is -4 minus lambda into 5 minus lambda plus 8. That equals to lambda square minus lambda minus 2. Characteristic equation is lambda square minus lambda minus 2 equals to 0. So this is a quadratic equation. So solving this equation, we'll get lambda is equals to 2 or lambda is equals to -. So what are the eigenvalues? The eigenvalues of here 2 and -. Now we have to find eigenvectors corresponding to the eigenvalues lambda is equals to 2 and lambda is equals to -1. The corresponding eigenvectors are found by using these values of lambda in the equation a minus lambda a2 of x equals to this null matrix. There are many eigenvectors corresponding to each eigenvalue. This is from the definition of eigenvector ax equals to lambda. Right? Now lambda equals to 2. To solve the equation a minus 2i2 of x equals to null matrix for x. The matrix a minus 2i2 is obtained by subtracting 2 from the diagonal elements of A. We get this is here you write lambda is equals to -4 minus 2 minus 6 3 5 minus 2. So -4 minus 2 minus 6 minus 6 3 3. X vector is x1 x2 equals to 0 0. So this leads to the system of equations minus 6x1 minus 6x2 equals to 0, 3x1 plus 3x2 equals to 0. So following this, x1 equals to minus 6. The solutions to this system of equations are x1 equals to minus k, x1 equals to minus r, x2 equals to r, where r is a scalar. Thus the eigenvectors of A corresponding to lambda is equals to r non-zero vectors of the form or into -1 1. Now eigenvector corresponding to lambda equals to -1. So we solve the equation a plus 1 into i2 of x equals to null matrix for x. So again same thing. So a plus 1 into i2 is obtained by adding 1 to the diagonal elements of A. We get -3 minus 6 3 6 x1 x2 equals to this null matrix. So this we can write as -3x1 minus 6x2 equals to 0, 3x1 plus 6x2 equals to 0. So solving this, we get x1 equals to -2x2. The solution to this system of equations are x1 equals to -2s and x2 equals to x, where s is a scalar. The eigenvectors of A corresponding to lambda equals to -1 are non-zero vectors of the form into -2